Evaluate the definite integral using integration by parts. And the definite integral is going from 0 to t. And the function is e to the s times the sine of parentheses t minus s times ds. So in this problem here, we're going to let u equal the sine of t minus s. And then dv is going to equal e to the s ds. So let's take the derivative with respect to s. So the derivative of sine is cosine of t minus s. And then the derivative of t minus s with respect to s is going to be -1, because the derivative of negative s is -1, and that's ds. So therefore du is going to be negative cosine of t minus s ds. And therefore v is going to be the antiderivative of e to the s, which is e to the s. Now in step number 3, we're going to go ahead and write our original question. And then we have u times v going from 0 to t minus the integral 0 to t v du. So we know that u is the sine of t minus s, and we're multiplying that by e to the s. So we have e to the s times the sine of t minus s going from 0 to t minus the integral going from 0 to t of v du. So that would be e to the s times du, which is negative cosine t minus s. So that's going to be a negative e to the s times the cosine of t minus s ds. Okay, so now we're going to go ahead and simplify. So we have e to the s times the sine of t minus s going from 0 to t. This negative times this negative makes that a positive, going from 0 to t. And we have e to the s times the cosine of t minus s ds. Okay, so now it looks like what we're going to have to do is we're going to have to, over here, integrate by parts again. So let's go ahead and do that. So we're going to go ahead and then integrate by parts. So we have 0 to t, and instead of using the upper and lower bounds, we can just use just the integral and then substitute it back in. So we have e to the s times the cosine of t minus s ds. Okay, so what do we need to do? We first need to identify what is u going to be, but we're going to call this capital U. So here we're going to let capital U, which is going to equal the cosine of t minus s, and then dv is going to equal e to the s ds. So again, capital V. So therefore, we're going to take the derivative of both sides. So d capital U is now going to be, well, the derivative of cosine is going to be negative sine times t minus s, and the derivative of negative s is -1 ds. And so if we simplify that a little further, a negative times a negative is going to give us a positive. So this is the sine of t minus s ds. And then capital V is going to equal e to the s. Okay, so now we have the integral of e to the s times the cosine of t minus s ds. And this is u times v minus v du. So let's go ahead and put that in there. So we have capital U, and we know that capital U in this example is cosine t minus s, and we're multiplying it by v. So we have e to the s times the cosine of t minus s, and then minus the integral of v du. So that's going to be e to the s times the sine of t minus s ds. And so therefore there is our integral, and then we're going to substitute that back into our problem here. So let's go ahead and do that. So we have e to the s times the sine of t minus s going from 0 to t, plus we have, now looking at this, e to the s times the cosine of t minus s, and that's also going from 0 to t, and then minus the integral from 0 to t, e to the s times the sine of t minus s ds. Okay, so now that we have that, what we're going to do is, you can see that we're going to end up going back to the original integral. So we're going to bring that down over here, and we're going to have 0 to t e to the s times the sine of, so let's go ahead and rewrite that. I'm going to rewrite that up here. So that's e to the s times the sine of t minus s ds. So this is e to the s times the sine of t minus s ds. Now if you notice here, we're going to bring that to the other side. So this is plus 1. And then we're going to add this integral to this side of the equation. And so if we do that, this gives us 0. Over here we get 2 times 0 to the t e to the power of s times the sine of t minus s ds. Okay, and then let's not forget about this 2 over here. But what we're going to do first is evaluate these two. So we have the following. We're going to substitute t in for s. So we have e to the t times the sine of t minus t minus e to the 0 times the sine of t minus 0 plus e to the t times the cosine of t minus t minus e to the 0 times the cosine of t minus 0. Okay, so let's go ahead and continue. So we have 2 times 0 to t e to the s times the sine of t minus s ds. So over here, we end up getting e to the t times the sine of 0 minus e to the 0, which is 1, times the sine of t minus 0, which is the sine of t, plus over here we have e to the t times the cosine of 0, minus 1 times the cosine of t. So we know that the sine of 0 is 0, and 0 times e to the t is 0, minus we have the sine of t, plus the cosine of 0 is 1, so 1 times e to the t is e to the t, and that's minus the cosine of t. Okay, and so now let's just kind of reorganize this. So again, we have, well, we can divide first by 2. So we're going to divide everything by 2. And so we end up getting the following integral: 0 to t e to the s times the sine of t minus s ds is going to equal 1/2. And now we're just going to reorder this. So we have positive e to the t minus the cosine of t minus the sine of t. And therefore there is our result.